Alright, so you guys did the front page together. For the first one, what is A? It's what? What's the number in front of x squared? 1. What's B? -3. What's C? -18. And what was your axis of symmetry for the first one? It's what? -3/2. Did anybody get anything different? I got 3/2. Anybody else get 3/2? Okay. It should be 3/2. I'm sure. When you complete the square, weren't your factors x minus 3/2 and x minus 3/2? That makes your axis of symmetry x equals 3/2, because your vertex would start at positive 3/2, because you're moving to the right. Alright, for the next one was A. 1, B was 5, C was 6, okay, axis of symmetry. -5/2. Because when you complete the square here, wasn't your factors x plus 5/2, and then you squared it? So you're moving to the left? Yeah? Alright. This one, A, 2, B, -5, C, 3, axis of symmetry, 5/4. X equals 5/4. Okay. Next one, A, 3, B, -5, C, -2, axis of symmetry, 5/6. X equals 5/6. Okay. I know. In the next one, what's A? 6. What's B? 7. C? -3. Axis of symmetry. X equals what? Negative what? -7/12? I thought you said 5. Hey, what did we notice? All of them are fractions. Good. Your axis of symmetry starts with x equals, right? What was your pattern between A, B, and C and your axis of symmetry? How do you get the top of your axis of symmetry? Oh, okay, close. So you're saying that it has a relationship with B. So like here we've got -7, and then your B was 7. It's what? The opposite B. How do we do that? B times -1 or negative B, right? What about the denominator? What happened there? Not quite. Because A plus B in the last one would be 13, wouldn't it?
2A.
Oh, it is 2A. That's your axis of symmetry. We didn't show you that formula first because you really need to know how to find it by factoring and by completing the square, but this always works. It's always -B/2A, where B and A come from standard form. Flip it when you're ready. We're going to learn, in Note Set 5, we're going to learn our last way to solve quadratic equations, but before that we have 4 ways that we've already done. What's one of those ways? It's what? Factoring. That's actually number 3, so factoring. If you factor a quadratic equation, what do you do after factoring to solve it? Nope. It says, remember, always set equal to 0. It makes you happy and you can solve it. So if you're factoring, you got to set it equal to 0, factor it, and then use what? Zero product property. Yes. What's the downside to factoring? It can sometimes be time consuming. What else? It's not always factorable. So this doesn't always work. So it doesn't always work. The upside is that if it's nicely factorable, it'll take you a very short amount of time, right? So if it's nice, it shouldn't take you that much time. It is quick when it does work, but it doesn't always work. Not everything is factorable. What's another way we've learned how to solve quadratics? That's higher than quadratics because that would be 4 terms. Completing the square, so we can do that for number 2, completing the square. No, quad is 2. Exponent of 2. Not in math class, it's not. Completing the square, and then after you complete the square, you've got it in vertex form, and after you get it in vertex form, then you can solve by square roots. What is the downside to completing the square? Time consuming. Sometimes it's really difficult, right? So this is time consuming because you got to think, you got to put it in vertex form, and then you got to solve by square roots, and you end up with an absolute value, and then you got to do piecewise and all of that junk, right? So time consuming. Tell me the upside of completing the square. The positive about it. So we completed the square a few times. We got rational numbers, right? Can we complete the square if we have irrational numbers, like square roots that we don't know? Yeah. Can we complete the square with imaginary solutions? Yes, we did that yesterday, right? Or the day before yesterday. So does completing the square ever not work? No, it always works. So an upside to this is that it always works. Okay. The first way that we learned how to solve, we never really actually just straight up solved that way. But we kind of used it to check our work along the way. What did we use to check our work along the way? Okay, and there's something that we did with most of our solving problems to kind of like make sense of it. Graph it. So graphing. Tell me the downside to graphing. Not always accurate. Correct. What else? What if we graph a quadratic that has irrational solutions? Is that going to be graphed? Not really. What about if they have imaginary solutions? That's not even going to touch the x-axis, right? So it doesn't always work. And sometimes it's not nice. So it doesn't always work. And sometimes it's not nice, but we'll just say it doesn't always work. So right now, graphing, if it works out, is really nice, fast. Completing the square always works, but it's time consuming. Factoring doesn't always work. Sometimes it's fast. What about the fourth way? This one is not something that we've really mentioned out of the gate, but if it's already in vertex form, then we can extract the square. So an example would be like if we had x squared equals 12. Then you could just take the square root of both sides, and then you've got the absolute value of x is equal to the square root of 12. You simplify the square root, and you've got it. That one doesn't always work because that one really only works with vertex form. So the downside to this is that you need vertex form. And it kind of has to be like a nice vertex form, not really a complicated vertex form. The fifth way is what we're learning today, and that is quadratic formula. You learn the quadratic formula in Algebra 1. It should be your last resort because the opportunities to mess up quadratic formula is numerous. There's a lot of chances to mess up quadratic formula because it is very intricate and there are a lot of details that you can't miss. There's a lot of negatives, there's a lot of fractions, there's a square root in there. And so the opportunities to mess this up, there's a lot of them. So I would use it as a last resort. But the good news about quadratic formula is that it always works. So always works. So now you have two ways that always work. One way is completing the square and solving by square roots, where you got the absolute value and the piecewise. Second way is quadratic formula. It is very detailed, so you have to be very careful with quadratic formula. Other ways that I can ask you to solve, I could say find your solutions. So I could say find solutions. What else could I say other than solutions that would mean that you have to solve it? X-intercepts, I'm going to put that in the long blank on the end. X-intercepts. What else? Zeros. There's one more word. Roots. Those all mean the same thing. When I ask you for zeros or x-intercepts, both of those require ordered pairs. Technically, when I ask you for the zeros of a function, I'm asking you for the location where your function is equal to 0. So that would be an ordered pair. When I ask you for x-intercepts, I'm asking you for where it intercepts the x-axis, which is also a point on your graph. So if it says zeros or x-intercepts, that is your indicator to give me ordered pairs, kind of like we did on the opener. If I ask you for solutions or roots, you can just leave it as x equals. What questions do we have? Now, some of us were frightened today because B block was very tired after deriving the quadratic formula. Let me explain. The quadratic formula, okay, we're going to show why it works and that it works all the time ever. Because what is this the equation for? It's standard form of a quadratic or any quadratic? Any quadratic. So we're going to derive, which means show you where it comes from. It is going to be long. It's going to take some work. It is going to take the room that's on the page for it, okay? But the purpose of this is to show you that A, it works all the time for any quadratic ever, and B, show you where it comes from, and C, show you that you can do hard things, okay? So we're going to endure this with a great attitude, yeah? And then I promise the next page is easier. Yes? You ready? It'll be great. Hey, how do we solve this equation right here? So we have our solving methods up top, right? Can I factor it? Nope. Gonna have to complete the square. Let's do it. Yeah? So let's group 0 equals ax squared plus bx plus blank plus c minus blank. What do I know about a? It's multiplied by x squared, right? What do I have to do with a? Gonna have to take it out, right? So gonna have to take it out. 0 equals a times, what does that leave me with? X squared. How am I gonna take that out of b? B over a. And then x plus blank plus c minus blank. Okay, awesome. Now I'm ready to factor into a square, yes? Because I got x squared. So let's factor into a square. 0 equals a, and then I've got two factors. What are my factors going to start with? X and x. And then what am I going to do to b over a to get what's supposed to go in my factors? I got to take half of it, right? Well, if I take b over a and I multiply it by a half, what is it? 1/2 b8. So what we're doing, I'll show it out to the side. I'm taking b over a and I'm multiplying it by 1/2. So what's the top going to be? B. What's the bottom? 2a. So b over 2a. And my sign on that is positive, positive, because my b over a is positive. Now I got to go backwards. To go backwards, I multiply b over 2a times b over 2a. What's b times b? B squared. What's 2a times 2a? 4a squared. Okay. But that's not really a b squared over 4a squared, is it? It's really multiplied by a. So what you're doing there is you're taking a over 1 and you're multiplying it by b squared over 4a squared. Is there a common factor top and bottom? Yes, 1. There's also an a on the top of my first fraction and an a on the bottom of my second fraction, right? So a over a is just 1, right? So this a and one of my a's on the bottom go away. And so my numerator stays b squared. My denominator is now just 4a, because one of the a's out of the a squared went away with the a on the top. So this a and one of these a's made 1. So they went away. And this would be b squared over 4a. Hey, can I get common denominators out there with that c? Yeah, I could do that, right? So if I got common denominators, So this is really c over 1. Okay, if I want to get common denominators, how am I going to do that? Multiply by 4a top and bottom, right? What am I really multiplying by if I multiply that top and bottom? A 1. It's called a well-chosen 1 because you're multiplying 1, but you're choosing it wisely so that it kind of changes the way that it looks, but it doesn't change the quantity because you're only multiplying by 1. 4a times c is just 4ac. And 1 times 4a is 4a. And I'm still subtracting b squared over 4a. Okay, awesome. So both of my fractions are now over 4a, so I have a common denominator of 4a. What should go first, the b squared or the 4ac? The b squared. Hey, what do you know about that b squared? What's the sign on it? Negative. I'm going to take that out and put it in front of my fraction. But what does that mean about 4ac? It was positive. If I took the negative out and I put it in front of my fraction, it's now going to be negative, so minus 4ac. Is everybody following me? Anybody lost? It's just math magic right here. What are we ready for? Vertex form, yeah. 0 equals a times x plus b over 2a squared minus b squared minus 4ac over 4a. Okay? How do I solve? Not yet. I gotta get what's being squared by itself before I square root. Add my fraction over. So add b squared minus 4ac over 4a to both sides. So that's going to give me b squared minus 4ac over 4a is equal to a times x plus b over 2a, and that's all squared. Now what? Almost. Divide by a. But I don't know how to divide a fraction by a. What's the same thing as dividing by a? Multiplying by 1 over a. So my numerator is not going to change because it's only multiplying by 1. So b squared minus 4ac stays the same. But a times 4a in my denominator would be 4a squared. And that equals x plus b over 2a squared. Okay, cool. We're getting there. Now we're ready for what? The square root. Square root both sides. Do I have... Oh, yeah, I have plenty of room. I cannot take the square root of b squared separately from 4ac because they're subtracting. So the square root is going to stay on my numerator. So the square root of b squared minus 4ac over, what do you know about 4a squared? It's a perfect square. What's the square root of 4a squared? 2a. Equals, what do we get on the right side that makes this a little painful? Absolute value of x plus b over 2a. I think you're approaching the bottom of the page, and so am I. So I'm going to bring this up here. Do what? No, it's fine. You're going to work in groups today, if that makes you feel better. All right. If we just had absolute value, we're ready for piecewise, yes? The first piecewise is going to be x plus b over 2a, is that correct? And then negative times x plus b over 2a. What does the plus b over 2a do to your graph? Moves you left b over 2a. So it's going to move you on the x-axis to negative b over 2a. So the first one will be x's are greater than or equal to negative b over 2a. And the second one will be for all x's less than negative b over 2a. We're getting there. Hey, haven't you seen negative b over 2a before? What was that? The axis of symmetry. This is your AOS. That should happen, right? We learned that note set 4, we learned that, yeah? Maybe note set 3. From here, I can have x is greater than or equal to negative b over 2a. That equation is going to be x plus b over 2a is equal to the square root. Come on. There we go. The square root of b squared minus 4ac over 2a. How do I solve that equation? Subtract b over 2a. You could, but that would make it a little bit harder. Just subtract the fraction. That fraction will be rational, so we'll have the rational fraction first, negative b over 2a. And then well, I just gave it away. The sign on your square root is positive. And so this will be plus b squared minus 4ac over 2a. That one's done. I know what my next one's supposed to be. What is it supposed to be? The only difference in your next solution should be a minus instead of a plus. And so we know what we should get. Let's show how we get it. So negative times, domain first. X is less than negative b over 2a. We'll have negative times x plus b over 2a is equal to the square root of b squared minus 4ac over 2a. And I want to divide by my negative 1 first, but what does that do? What's the only thing that does? Changes the sign on my fraction on the right side. That'll be negative square root of b squared minus 4ac over 2a. I know, we're almost done. And then from there, it's the same thing we did on the last one. Just subtract your fraction of b over 2a. That one's going to go first because it's going to be rational, so negative b over 2a. And then minus the square root of b squared minus 4ac over 2a. If I wanted to write my solutions as one solution together, what would it say? What do they both have in common? They're both x equals. Do they both have negative b over 2a? Negative b over 2a. What's in the middle? Plus or minus, right? We had a plus in one and a minus in the other. And then we had the square root of b squared minus 4ac over 2a. That's your quadratic formula. It always works forever and ever because we just showed it. This is kind of like a proof of like, we took whatever quadratic you could ever have, ax squared plus bx plus c for any a, b, and c ever, and we showed that that will always be the solution. So this is your quadratic formula. The great news is you'll never have to do that again until you take college mathematics, I guess, if you wanted to. But you'll never have to do that again. You just use the formula now. As long as you can find a, b, and c, you just substitute them in, and then you simplify your formula. You ready to do that? Flip it. I didn't say that, yeah. You got it? Hey. What? This page. I'm going to do the first one with you, and then you're going to do the next two in your group, and then we're going to circle back and finish it at the end, and then we'll break for the day. Yeah. All right, so find the solutions by using the quadratic formula. You need to memorize the quadratic formula. I'm never going to give it to you, so you need to memorize it. But to use the quadratic formula, which was the thing in purple from the last page, what do you need to know? You need to memorize the purple thing, but you need to know A, B, and C, right? You need to know where they come from. They only come from standard form. You can't get them from vertex form, and you can't get them from factored form. So that means if you're going to use the quadratic formula, you need to see it in standard form. What is A for number 1? 1. What is B? -4. What is C? 4. Let's actually do number 3 together. I'm changing my plans. What is A for number 3? 2. What is B? -12. What is C? 18. What do you notice? All multiples of 2. So is there a greatest common factor of 2? Let's take that out. So that'll give me 2 times what? X squared minus 6x plus 9. What would your A be there? 1, -6, and 9. What's the benefit to taking out your greatest common factor before you identify A, B, and C? More simple, smaller numbers, right? You can take a greatest common factor out and then do A, B, and C if there is a greatest common factor. Tell me when that greatest common factor is going to be important again. When is that 2 important again? What does that 2 mean? Graphing, because it means you're doing what? Vertical stretch by 2. So vertical stretch by 2 is something that we're going to have to keep in mind when we do our graph. Let's do the quadratic formula. So x equals -b, so negative, and then put parentheses. What is b? -6, that goes in your parentheses, so negative, and then parentheses, -6, over 2 times a, what is a? 1, and then plus or minus. On the top, you're going to have the square root. It's a big one. You're going to have b squared. B needs to be in parentheses. What is b? -6. Close it, square it. It's b squared. Minus 4 times a, which is 1, times c, which is 9. And then that's all being divided by 2a, so 2 times 1. Simplify it one chunk at a time. So we're going to start at the beginning. What's -6? 6. Over, what's 2 times 1? 2. Plus or minus the square root. What is -6 squared? 36. Now, let's try to multiply these 3 numbers together. What's -4 times 1? -4, then times 9. -36. All over, what's 2 times 1? 2. So I got x equals. Every time I write a new line, I write x equals to remind myself of what I'm finding here. What is 6 divided by 2? 3. Plus or minus. What's 36 minus 36? 0. So I have the square root of 0 over 2. What is the square root of 0? 0. So I got 3 plus or minus. The square root of 0 is 0 divided by 2, which is 0. So 3 plus or minus 0. So I'm going to have x equals, what's 3 plus 0? 3. What's 3 minus 0? 3 minus 0? It's also 3. So this is a multiplicity of 2. Yes. -4 times 1 is -4. Then you multiply that by 9, which is -36. What does that mean? That it only crosses the x-axis once. And what did we do on the opener when it only crossed once? You bounce back, right? So we've got 3, 0. Hey, remember what we talked about here? What is this 3? Your axis of symmetry. So let's graph that. If I graph my axis of symmetry at x equals 3, what's going to happen? It cuts through my x-intercept, right? So my x-intercept is also my vertex. And we have a vertical stretch by 2. So usually you'd go out 1, up 1, because 1 squared is 1. You'd go out 2, up 4, because 2 squared is 4. In this case, we got to double how much we're going up. So we're going to go out 1, up 2. And instead of out 2, up 4, you're going to go out 2, up 8. And that's always from the vertex. You always go right back to the vertex to do that. You don't keep it going point after point. You go back to the vertex to do that. Get the idea? So the first number that you find out of your first fraction is your axis of symmetry, and then the whole thing together is your x-intercepts. Ready to do the other two? I'm going to give you 10 minutes. Do number 1, do number 2 with a partner, okay? And then we're going to circle back at the end of 10 minutes to discuss the last 3 questions, last 4 questions? We're going to do these together. So 10 minutes, do number 1 and 2 with a partner, talk about it, get it correct, and then we'll talk about the bottom. Go. Why are there lines everywhere?
No, you got it.
That's right? And then the next one, you did this, yes. Multiplicity of 2. I don't know why there's lines everywhere. I'm sorry about that. My recorder messed up, I guess. Yes? We okay? Staying afloat? So the ... dots mean that you have the work there for that, yes? Let's talk about it, and then you'll have some time for homework. How many x-intercepts did each of these have? 1. How many solutions did each of these have? 2. What do we call it when we only have 1 x-intercept but 2 solutions? Double root. And in each of these, those double roots were also coincidentally what? It was the same what? The double root was also the same as the x-intercept, and it was the same as the vertex. That happened in every single one of these because of the discriminant. And you're going to say, Miss B, what did you just say? The discriminant. The discriminant. You need to know what that is. That is found underneath your square root of your quadratic formula. So it is b squared minus 4ac. If we backtrack to the problems you just did, it's whatever you're taking the square root of. And so in the last one, we took the square root of 0. In the middle one, what did you take the square root of? 0. In the first one, what did you take the square root of? 0. So in all of these, the discriminant was equal to 0. That's why you ended up with a double root, because you took your axis of symmetry and you added 0, and then you subtracted 0, so your axis of symmetry was the same as your x-intercept x value. And so if b squared minus 4ac equals 0, you're taking the square root of 0, then what is true about the x value of the vertex and the x-intercept? Or the x-intercept. They're the same. Notice that all of these could have been factored as perfect square trinomials, yes? That's what happens when we have perfect square trinomials. When we do the quadratic formula, you get the square root of 0, which is a perfect square, right? This means that we are going to have to do 3 pages on Monday, so we're going to have to do these graphs. It'll be very much the same as what we did today. I'll do 1 with you, and then you'll do 2 on your own, then we'll talk about them. Same thing for this next page. We'll do 1 together. You'll do 2 on your own. We'll talk about them. And then the last page, we're going to really get into solving using the quadratic formula from just the equations, not graphing them at the same time. Okay? Questions about what we're doing on Monday? Remember, you got a quiz on Tuesday, and then a unit test next Friday. Now you got time to work on your homework. About 8 minutes. Let me know if you need anything or if you have any questions.